Hello everyone, my name is Animesh Gupta and I am from ENC batch. I worked on the reproduction of the original code base.
Hello all, I'm Aryaman Grover from ENC and I was involved with the API of the model.
Hello everyone, I'm Aniket Biswas from ENC. I worked on the user interface and the user experience of the application.
Hi everyone, I'm Shaurya Jain from ENC and I've worked on the model and the documentation of the project.
Hello everyone, we will be presenting our Capstone project titled E-Commerce TryOn. Our project aims to provide a solution for e-commerce websites to let users try on the clothing articles offered. By simply uploading a photo of themselves, they will be shown how they would look in the clothing article on their choice, using a generative model. Furthermore, the model also provides repose functionality which allows users to generate images of how they would look in different poses. There were pre-existing solutions present for the problem, but there were numerous shortcomings with those. 1. They had problems with preserving the facial features and reproducing them in the resulting images. 2. There were problems with producing realistic folds and creases on the clothes which occur with any real person wearing clothes. Focusing on these shortcomings, we used the following solutions with the motive of achieving better results. Why style GAN over CNN? Rendering photorealistic human images is particularly challenging task in traditional computer graphics pipelines. The proposed solution focuses on working with style GAN over CNN as it enables us to give 1. Pose-conditional input for controlling the poses. 2. Varying spatial modulation for different appearances. Looking at the challenges in designing TryOn framework. Firstly, it is tedious to effectively capture the 3D geometry and appearance of the person, as virtual TryOn requires to try the clothes with different poses. Therefore, we need control poses in the 3D shape. Finally, we need to synthesize the complicated wrinkles pattern which are generally present in loose clothing. For the first issue, authors proposed to integrate surface-based method with style GAN. For the second, they used left-right symmetry which is a prominent feature of the human anatomy. Lastly, they introduced the use of spatial variation in the latent space of the style GAN framework used. Our main objective here is to create an image-preserving appearance of the person in the input image with desired pose provided as the target, based on input image and a given target pose. Firstly, we used an pose-guided style GAN2 generator. Pose features are calculated using DensePose. Secondly, we used a coordinate completion model on the source and target poses to create a target coordinate which contains correspondence between the source and target images. We further discussed the coordinate completion model in detail, where our main aim was to learn to reuse the local features of visible parts in the source image for invisible parts. We first used a mesh grid in the dense pose of the source image to map the base coordinate C base and symmetric counterpart C mirrored, as human body are left-right symmetrical. We then trained the model to minimize the L1 loss between predicted coordinates and input coordinates. Thirdly, to encode appearance information from the source, we used an FPN network to encode the source image to multi-scale features according to the target pose. In the source feature generator, we used pre-trained coordinate completion model to obtain target image space coordinates T-cord. This helped to wrap the source pose features to the target pose. We then combined them and passed it to an FPN network to get multi-scales wrapped appearance features. Fourthly, before passing the wrapped features to style GAN, we used an affine parameter network to compute alpha and beta as required in the style GAN network. Lastly, we also used losses like phase loss so as to retain the identity of the source image. For evaluation, authors used the deep fashion dataset. Authors evaluated the proposed method with different baselines. Authors evaluate quantitatively using the 4 evaluation metrics. The method which we used surpasses previous proposed approaches. Please refer to the original paper for more details. Our used method was able to better retain the face identity when compared with ground truth and GFLA. Please refer to the original paper for more. We also created a web-based UI, so that researchers, evaluators and users can easily try e-commerce TryOn. We would like to thank you for your time and attention.